That is for today. We're going to introduce some new material. And then tomorrow I'm out, so Mr. Supp's going to be here. So you guys are going to have the chance just to do some practice with it. Okay? He will have an answer key. You know, if you realize that you're not getting it, don't freak out because it's just our first day doing it. So work with other people in the room. Don't freak out, okay? So we're going to take a small break from gases for a little bit. And we're going to get into some more fun reaction stuff that we can actually do in the lab. And that's with solutions. Which means, dun, dun, dun. Go review them. Solubility rules. Okay. Also a good thing to review coming up because, you know, our finals in less than 2 months at this point. So not that there will be an explicit solubility rule section, but it's going to come up on for several other units. So knowing those solubility rules, super important. If you need to review naming because as I learned down the quiz, several of you guys had issues doing things like naming ammonium nitrate. So go review your naming. Go review those polyatomics. Okay. Ammonium nitrate, NH4, NO3. So, all right. No, we're good? Okay. So guys, with solutions, the difference between working with solutions and working with solids isn't going to be huge, but we've got a different way to talk about how much we have. So when we're looking at solutions, it's generally going to be a combination of two things. So solutions are made up of solvents and are going to be made up of your solute. So what's the difference between a solute and a solvent? Katie. So solutes are dissolved by the solvent. Good. So solute is what you put into the solution, right? Generally a solid that goes in. Solvent is going to be the liquid that does the dissolving. In 99% of cases that we're going to be talking about, our solvent is going to be what? Water. Right, so in almost all these cases, when we're talking about aqueous solutions, that's because we have water as our solvent. And our solute is what gets dissolved in it. So if we have salt water, right, the salt, NaCl, is going to be our solute. Our water is going to be our solvent. And the salt-water combination is going to be the solution. Make sense? So getting those three terms straight, definitely super important. So when we're talking about all of this, we often want to take a look at how much solute are we putting into the solution. So if we think about water, right, if we've got a big pan of salt water, we can put just a tiny little sprinkle of salt in, or we can put, you know, an entire cup of salt in. How would you just, what words do you think you would describe the difference between those? What I'm thinking of, one begins with the D and one begins with a C. Dissolved, that's what it's, I mean, it's dissolved in there, but it's not quite what I'm thinking of. To describe the differences between those two solutions. Okay, I'm going to come back to that. D and C. Hold on. Okay. Okay, pick one. E. Okay. Hold on. Concentrated. What's the other one? What's the opposite of concentrated? Dilute. Okay, so dilute versus concentrated. So a dilute solution has very little solute per amount of solvent. A concentrated solution will have more solute per amount of solvent. Make sense? Now, Helen, what was that word that you pulled up that you said a minute ago? Saturated. The saturation will be saturated, okay? So when a solution is saturated, any idea of what that means? It's not just fully dissolved. Fully dissolved means whatever you put in there completely dissolves. Candace, what were you saying? Right, so a saturated solution means you have the maximum amount of solute that will dissolve in your solution. So your solute is maxed out. So if you were to put in, so if I had a saturated sodium chloride solution, if I put in any more sodium chloride, it's not going to dissolve. Okay? Everything has limits in terms of how much will dissolve. If you put, so the question was, if you put something else in there, will it still dissolve? It depends on what you're putting in. When we get to, in May, when we talk about equilibrium, this is where this comes in. And there's something called common ion effect. And that's where all that plays in. It's a lot more complicated. So, yeah, it is pretty fun, actually. So, but that's not for about another month or so. So if we have not maxed out how much solute can go in there, right? If there's less than the maximum solute, what do you think the word's going to be? Unsaturated. And in rare cases, you can have something called a supersaturated solution. There's less solute than the max that a solution can handle. Supersaturated is when you actually manage to get more than is possible in your solution. And that usually happens when you heat up the solution, dissolve it, and then cool it back down. So an example is sugar water. Okay, if you just put sugar in water, sugar doesn't usually dissolve very well in water. But if you heat it up, if you heat up your water and you dissolve your sugar, you can get that solution. And when you cool it back down, if you cool it carefully enough, the sugar will stay dissolved and it'll generally be kind of thick and you'll get something called a simple syrup. Right? You know, if you have it in 1-to-1 portions where you say you have 1 cup of water, 1 cup of sugar, that'll be a simple syrup. If you just dissolve the sugar in water at room temperature, it won't dissolve. If you heat it up and then once it cools back down, that's what we call supersaturated solution. So it'll still stay in solution form. It just is going to be a little bit more finicky. Okay. Make sense? So I know we've kind of hit a lot of vocab at the beginning of this. We've got saturated, unsaturated, supersaturated, dilute, concentrated, solution, solvent, solute. A lot of S's today, right? So definitely key to keep, you know, keeping a lot of the strategies, just keeping track of the vocabulary. But now Here's the fun, well, at least what I think is the fun stuff, which is the math part. Oh, so when we talk about concentration, we want to be able to talk about it in some sort of quantifiable way. So generally the way we talk about concentration is by a unit called molarity. And so the definition of molarity is moles of solute over liters of solution. Moles of solute over liters of solution. So let's do some math. I want to calculate the molarity of a solution with 3 grams of sodium chloride dissolved in a 500 milliliter solution. How would I go about figuring out the molarity of that? Convert to moles, our favorite. So what's the molar mass of NaCl? Yep. But just some math that you want. 58.44 grams. Good, this is awesome. You guys are starting to get this table memorized a little bit. Well, that's a fun thing. It doesn't have to happen, right? You're not necessarily always going to have it memorized, but you guys are starting to pick up. When you use it enough, it's starting to come naturally. So, okay. How many moles is this? Yeah, you actually need calculators. If you're afraid your calculator's going to run out of battery, I would change the batteries tonight. 0.05133 moles. Right. And remember, when we're in the middle steps of a problem, I've always recommended bring out your sig figs by a few steps, right? Don't do your final rounding till the end. What? Because if you round it here and then you do another step and you have to round it again, you're rounding a rounded number. So why not just leave it, right? Bring out a few more sig figs. It's the answer at the end that we really care about the sig figs with. So for molarity, we have 0.05133 moles over what? 0.5 liters. So what does that get us for molarity? .103, and we say that with a capital M. So the unit is capital M. If I were to say this out loud, it'd be a 0.103 molar solution of NaCl. Okay, the molarity of the solution is 0.103 molar. Does that make sense, guys? Okay. I am going to give you guys a problem to work it on your own. So, if I have, oh my gosh, oh, it's still recording. Okay, I don't know why it's, okay, we're okay. All right, what is the volume of a 2.38 molar hydrochloric acid solution with 0.593 grams of HCl. What is the volume of a 2.38 molar HCl solution that contains 0.593 grams of HCl? Pause the video, we can come back. So what's the first step we do? Convert grams to moles. So 0.593 grams of HCl times 1 mole over what's the mass? So what do we get for mass? Or for moles? 0.01626 moles. Okay, so now we got to put an equation, right? So let's think about this equation in a few ways. We've got moles of solute over our volume is going to equal molarity, right? It's kind of annoying trying to solve for volume because volume's at the bottom, you know, silly algebra. So I'm going to do one thing to make your life a little bit easier, and I'm going to say moles is equal to molarity times volume. Another way to look at it. Make sense? So if I have 0.01626 is equal to 2.38 times our volume, what is our volume going to be? One zero zero 683 liters, which is the same thing as 6.83 milliliters. Yeah, you can leave in liters. Make sense? Okay, one other application of this that is super, super useful, especially if you're working in a lab, is the idea of dilution. Okay, so if I am doing a lab with you guys, which we have done a few times this year, which say uses hydrochloric acid, okay, I go into the back room and I do not go and buy a lot of different concentrations of hydrochloric acid solution. To do that would be expensive and really impractical. So when I buy my hydrochloric acid, which I will show you guys when everyone is here what it looks like, I buy a big jug. Wow, that's a horrible looking jug. Let's go with it. Of 12.1 molar hydrochloric acid. Now, for you guys, as first year chem students, the most I usually have you working with is 1 molar. Even that might be a stretch. Most of what we've done this year, 0.1 molar, right? 0.5 molar, maybe max. Mostly because at those concentrations, if you get a little bit on your skin, no big deal, right? You wash it off, you're still going to be pretty safe. 12 molar, on the other hand, if I got that on my skin, I'd be talking some pretty serious burns. But the advantage is I can buy a big giant container of it and it's going to last me years. And so instead of paying for a lot of water, I'm paying for a lot of solute because I can go and do the dilutions, right? So let's say I have a lab experiment that you guys are running where you're making 1 molar solution, okay? And I want to make 250 milliliters of solution for you guys. So I need to figure out how I'm going to do this. So let's think about this procedurally. One big clue, the one thing you always want to do, add acid, add acid. So you always add acid to water. You do not add water to acid. So when you're diluting something, okay, you want to add your acid to a solution of water. Reason being, when you dilute something, it is generally going to be exothermic. It's going to give off some heat. So if you have some water there, it helps temper some of that energy transfer. Makes it a little bit safer. You also have less issues with splashing too. So when you're pouring it for yourself, it's going to be a safer process. But let's say I have my container of water. And let's say this green chunk is my concentrated acid. Okay. So that's my concentrated acid right there. If we think about it, the moles of acid, are they coming from a small amount of my concentrated solution, a large amount of my concentrated solution? What? Do you think I'm going to have to pour a lot of this in here, a small amount? Relatively small amount, right? But all of the moles of acid are coming from this. Now, what can we say about the moles of acid of the actual HCl that we take out of the big container versus what we're putting into the small container? What's going to be in the small container? How can we compare that number of moles? Just comparing that number of moles. So if we think all of the moles of HCl that we take out of here has got to go in here, right? Is that the only source of HCl going to be in the solution? Yeah, we're just putting it into water. So if we can think about it this way, remember, going back up here, the moles we said is molarity times volume, right? So the molarity times the volume of our concentrated solution, that number of moles has got to equal the concentration times volume of the dilute solution. Right, the dilute solution is going to have a lower concentration, but a higher volume because we're pouring it into more water. Does that make sense? So the equation we really get out of this is M1V1 is equal to M2V2. And this equation works, and specifically only works for dilutions. We're not worrying about reacting anything, we're just diluting. So if I go back to this problem before, where if I had 12.1 molar concentrated solution, and I wanted to make 250 mils of 1 molar, I'll figure out how to do that. First, I've got to figure out how much of my concentrated solution I need. Right, so I'm going to use M1V1 is equal to M2V2. And I'm going to say, okay, my concentrated solution, I've got a 12.1 molar. I have an unknown volume. That's going to equal the volume of my concentrated solution, the 1 times the 0.250 liters. Which, when I do the math, gets me 0.0207 or liters, or 20.7 milliliters. Okay. So if I were asking directions on how to do this, what I would say would be, different color here, add 20.7 milliliters of 12.1 molar HCl to 229.3 milliliters of water. Where did that 229.3 come from? 250 minus the 20.7, right? Because our total volume of the new solution needs to be 250 milliliters. And everything we're doing, we're assuming our volumes can just be additive. Everything can add straight up. So if they're asking for a calculation, you use this. If they're asking for a descriptor, right, add acid to water. Add 20.7 milliliters of acid to 229.3 milliliters of water. Okay. So we've definitely done a lot today. This has been pretty dense. This video is also going to get posted on YouTube. I'll put the link up on Classroom. So that way for people who are watching at home, you guys can see it. Plus, if you guys in class want to watch it again, you've got that option as well. From here, fairly shortly, we're going to take this into Stoic. Okay. This is one of the big things we've got going probably, yeah, I think it's going to happen next week, is that we're going to use all this information. You guys are going to solve, there's a murder that needs to be solved. So you guys are going to be doing a lab to try to figure out who the murderer is. Okay. Which means it's the kind of lab that you guys have to figure out your own procedures and all your own stuff with. Okay. It's pretty fun. Homework is up on Classroom. It's a few problems, it's some reading that goes over what we talked about and some problems. Okay.